Good morning, everybody. Sorry for the late post. I've been struggling getting out of bed because my back was all messed up from doing some work around the house last night. So you might hear some moaning and groaning throughout this. Quick thing, people have asked me to go over this again. So I'm doing I'm just doing two examples for today. I'm going to do two hard ones, two difficult, challenging ones to help you guys through today's work. And then you guys can reference yesterday's video to also assist you with today's repeat lesson from yesterday with some different work. So here is the first of two examples. I got y equals 2x squared plus 4x minus 3. So first things first, like we per usual, divide this first term out of the first two. So I got x squared plus 2x minus 3. Half of this squared happens to be 1. I brought in a positive 2 that was in here. I must take it out. So y equals 2x plus 1 squared minus 5. So now I know my vertex. I'm hoping this is now getting kind of easy for you. You guys see this okay? I got, let's go hard. I'll move this. That's probably better. Your vertex is -1, -5. Now, I want you guys today to use the completing the square, use this vertex form to now solve for the two solutions. So now let's make this equal to 0 to solve. Add 5, add 5. 5 equals 2 times parentheses x plus 1 squared. Divide by 2 on both sides. And I'm going to go through this rather quick because I think you guys understand the basic steps going on based on my conversations yesterday. So we know that eventually we're going to take the square root of 5 halves, which is 2.5, is equal to the square root of x plus 1 squared. So now this is going to be estimated at about 1.6 equals x plus 1. Subtract 1 from both sides. So I'm going to have my two x-intercepts be at x equals -1 plus 1.6, and I'm going to have -1 minus 1.6 right there. So I know that one x-intercept is going to be -1 plus this is just 0.6. The other one is -2.6. So I'm going to graph. I'm going to erase this now. I'm going to do some graphing for you. And guys, you guys can estimate where the points are at. This is all about the concept. I'm going to give you guys some new vocabulary that you'll be seeing in tomorrow's work as well. So if I got my graph right here, okay, I got my vertex at -1, -5, -1, -1, 2, 3, 4, 5. And I got a x-intercept, and again, these are just estimated, guys, so graph paper is going to have a much better estimated looking graph in mine. So -2.6 is right about here, okay, and positive 0.6 is right about there. Now I can use those points, but I also want you guys to know, I erased this equation, didn't mean to, y equals 2x squared plus 4x minus 3. I want you guys to now start, if you can, try to always find the y-intercept of these graphs, because you're going to see that language in tomorrow's work and future work. So real easy to find the y-intercept. Replace x with 0. Very easy. When x is 0, y happens to be -3, -1, 2, 3. And I hope this is getting easier because this vertex right here, the x value of this vertex happens to be also called our axis of symmetry, or line of symmetry, because that's where everything is symmetrical on both sides, just like we have in the absolute value function. So that means I went to the right one and up 2, so I'm going to go to the left one and up 2, and the math will prove that when x is -2, y is -3. -2 squared is 4. 4 times 2 is 8. 4 times -2 is -8. These cancel off, and you're left with -3. So your graph can be graphed just like this, and you are all done with graphing that quadratic. Now, I'm going to do another one for you, and this is the last example, and then you have any questions, please see me in Zoom today. So, here we go. Alright, so I got one that says this. Y equals negative 3x squared plus 4x. Now I had a lot of questions of ones like this with no plus or minus c back here. So in that case, we still follow the same rules as before, guys. You divide this 3 out of these first two terms. Negative 3x squared. I'm sorry, not plus, because remember I'm doing 4 divided by negative 3. So now this is negative 4/3 x. I'm going to do this off to the side. Remember, I take half of this and square it, put that number there. Now, I hope your work with fractions is getting easier. So now this says negative 4/6. Please always use lowest terms. It makes life so much easier. Negative 4/6 reduced to lowest terms. Jesus, is negative 2/3. And remember, I now have to square this, so now this says 4/9. I put my 4/9 right there, okay? I hope that this makes sense what I did. I'm just writing down all my thinking for how I got from this number to this number. Now how do I get here? I take the opposite of whatever this product is. So I know negative 3 times 4/9, negative 3 times 4/9 is equal to negative 12/9, which reduces to negative 4/3. Remember, I brought in a negative 4/3. I take it out, so now this says positive 4/3. So now I got y equals negative 3x squared minus this number right here. Sorry, not x squared there. Minus 2/3 squared plus 4/3. So I know my vertex is at 2/3, 4/3. Okay, there's my vertex. I got that all off to the side. I'll come back to that later. I want you guys to solve for this now. Here's why you always leave stuff in fraction form, because A, it's what I demand, and B, sometimes it'll work out really nice and clean because I hate decimals. So watch what happens. Subtract 4/3 from both sides. Now I got negative 4/3 equals negative 3 times x minus 2/3 squared. Because I'm dealing with a fraction, I want you guys to just, instead of dividing by negative 3, multiply both sides by negative 1/3. Because that does the exact same thing and it's a lot easier. Negative times negative is positive, so now this says positive 4/9 equals x minus 2/3 squared. Okay? Now, I like this because I got two perfect squares on numerator and denominator, and I know I have to square root both sides. And this doesn't come out a little nicer than expected. So now I'm going to have plus or minus 2/3 equals x minus 2/3. So now I know add 2/3 to both sides. So I got x is equal to 2/3 plus 2/3. And I got x is equal to 2/3 minus 2/3. So x equals 4/3 and x equals 0. So there are my other ones. Now I'm going to leave this equation up and I'm going to do the graph for you right now. Hoping this is making a little more sense. And again, I'm doing fractions on purpose today because you guys can estimate your answers, like where you're graphing it, just the shape. I know this is graphing upside down, so I'm going to put the majority of my graph in the negative region, like such, okay? Because my vertex is going to be right over here, so I know that the majority of it will be over here. So I'm going to try to space this out so you can see a better shape. Let me just do this up just a little bit more, hence why I use pencil. Alright, so 2/3 is just a little more than half, and 4/3 is just a little more than 1 for your y, so I'm going to say it's right about there. Well, I got a real easy point. I got 0, 0, that's 1 point. And I got another point at 4/3, 0. Well, we know if it's just a little more than 1 over here, it's just a little more than 1 right here. That's good enough. Now, I want to try to get one more definitive point. So when x is, look at here, when x is 1, Alright, when x is 1, this makes negative 3 plus 4. When x is 1, y is 1. How about when x is negative 1? Okay? When x is negative 1, it's going to be way down here because negative 1 squared is 1, negative 3 plus negative 4. Remember, this times negative 1 is negative 4, so that's negative 7. So when x is negative 1, y is negative 7. So I mean, moving on a little bit further. 1, 2, 3, 4, 5, 6, 7. Negative 1, 7. Now I went a little too far. This is not necessary. Okay? And this is good enough. If I had just this right here for the sake of what you're doing today, that is more than appropriate. So I hope this helps you guys out with these two difficult examples. You'll be seeing stuff like this in today's work. Pay attention to what it says in classroom for you guys to work on. I will see you guys at 12:30.